Hey, welcome back. In this video, we're going to show an example of finding a confidence interval for a population mean based on a small sample. Importantly, if we don't know the standard deviation of our population, which is often the case, we're going to have to use the student t-distribution to accomplish this. I want to emphasize at this point, a lot of this notation can seem very confusing. My goal in this video is to show you how this can be simplified and not so complicated. In doing the work of creating a confidence interval, we just need three things here. First and foremost, we need a way of finding a t-score. This can be through technology or a t-table. I'll talk about both of those when I go through the example. To find the t-score, it's determined by the confidence interval that we're looking at. Generally speaking, when we do actual statistical work, we'll be looking at 90, 95, or 99% confidence intervals. And then we need the degrees of freedom. This is a fancy word, and I won't even get into the depth of why we call it this. But importantly, in any case, when you're looking at a sample, the degrees of freedom is simply n minus 1, where n is the sample size. Once we have our t-score, we also need the standard deviation of our sample data and the mean of our sample data. The standard deviation will be used here to calculate this error bound, and what this does is just create this width of this interval that is centered on the mean of the sample data. And before we get directly into this example and doing these three steps, I want to emphasize that a t-score is very, very similar to a z-score that talks about these number of standard deviations we are away from the mean. Importantly, a t-distribution is not exactly normal, though is bell-shaped and has a lot of the same features as our normal distributions, or specifically our standard normal distribution. All right, in our example here, we're measuring the effectiveness of a pain relief treatment. What we've done is collected the sensory rate data from 15 subjects. So in this case, I want to just stop here and say, for our treatment, we'll have n equals 15. What this also means is that our degrees of freedom that we need, we'll denote that with df. That is 14, which is always just one less than the number in our sample. We're being asked to use this data to find a 95% confidence interval for the mean sensory data of the population. And before we get in the real work of solving this problem, I just want to make a quick comment on the notation. Specifically, this can look very complicated. This t sub alpha divided by 2. The alpha divided by 2 can be interpreted simply as the amount of area to the right of this interval. And importantly, if we're looking at a 95% confidence, we have 5% split between these two tails on the outside of this interval. We'll be looking at this area to the right would be 2.25%. Or in other words, what this 95% confidence interval is represented as a t-value would be t of 0.025. Importantly, again, as we actually do the work, you won't need to know this. I just want to make it clear. That's what this is representing here. And in practicality, won't require any work from you. All right, now we need to do the work of finding the t-score. We can do this in two ways generally. One, we can use technology, or we can use a t-table. Either works just fine. I'll first show the work of finding this t-score using a t-table here. So if we look at the t-table, what we can do, and often at the top of a t-table here, we'll have our t-values described like by this, with one tail or two tails. This would be a one-tail representation of the t-score. But the most useful t-tables at the very bottom usually will have these confidence intervals. So if we just go to the confidence interval for the 95%, and then what we do on the row is we're looking for our degrees of freedom to be 14. When we do that, we get a t-score equal to 2.145. So that's our t-score that we're going to be using in our work right here. Again, this value right here will help us with our error bound. We'll be multiplying it here by the standard deviation divided by the square root of the sample size. Technology like a TI calculator and Google Sheets also has a function that can output this t-value based on the confidence interval and the degrees of freedom. If you want to, for instance, use a TI calculator to compute the same thing, the function that you're going to use is inverse t, and it takes two inputs. The second input is the easiest. It's looking for the degrees of freedom. In this case, that would be 14. And then here, what it's looking for is an input of, it's the area to the left of the upper bound. So importantly, this number represents this confidence interval, but it's the confidence interval plus this lower tail right here. So what we'd actually input in this case is 97.5%. So 95% plus that 2.5% in that lower tail. We would write that as 0.975. All right, so that's the big first step and probably the most complicated, honestly, throughout this process is determining that t-score. Again, either using a t-table or technology. Honestly, for me, I think the t-table works pretty dang good and easily. Now we need to calculate the error bound. We have our t-value right here of 2.145. What we need to do now is calculate the standard deviation of our data and divide that by the square root of our n. Importantly here, what I'll do real fast is just using Google Sheets, and we could do this with any other technology or by hand if we wanted to, is I'll calculate the standard deviation and calculate the sample mean that I'll need in a second for this data set. All right, and I get that the standard deviation of this sample data set is 1.6722. And I got the mean of this data set at 8.2267. So now let's calculate the error bound for this confidence interval. We have E equals our t-score, which is 2.145, multiplied by the standard deviation we have here of 1.6722, divided by the square root of 15, where 15 is the size of our sample. And when I threw that in my calculator, I got 0.924. And now that I have this error, that's going to be plus or minus from the mean of my sample set, I just need to calculate the upper and the lower bounds of this confidence interval. So I have x bar minus E, which in this case would be 8.2267 minus my error bound here of 0.924. So I'll calculate that and the upper bound, which is my mean, plus this error, which again is 8.2267, now plus 0.924. And when I did that and rounded to 2 decimal places, I got 7.30 for my lower bound, and for my upper bound, I got 9.15. So all that work gave us that the 95% confidence interval for the mean sensory rate of the greater population would be from 7.30 to 9.15. And just quick note on this is using something called interval notation that you may or may not have seen before. But what this is simply describing is an interval of values with our lower bound and our upper bound. And finally, just to revisit of what the heck a confidence interval is, it's important what this means to say this is the 95% confidence interval is that with 95% confidence, we can estimate that the true population mean from this small sample of just 15, but we can estimate that the true population mean is between 7.30 and 9.15.